So now we'll see about the next topic, that is automata and its complexity. Okay. So here we are going to study about the essentiality of the automata, which is for our study, and also the limits of a complexity. We are going to address two important issues with respect to automata and its complexity. The first one is what can a computer do at all? We are going to check how much or what all are the tasks where the computer can do. So that is called as decidability. What can a computer do at all is called as decidability. And the problem that can be solved by a computer are called decidable. So the answer for this particular question is nothing but the decidable. Okay. Now, next issue is what can a computer do efficiently? So, if certain problems can be solved by a computer are considered as the decidable one. Now, whether the computer can solve the problems efficiently or not is the second issue, and that is called as interactability. In this, the problem can be solved by a computer using no more time. Okay, within a short time itself, the problem which the computer can be solved. That is, in less amount of time only, the computer can solve. Then slowly growing functions of the size of the input are called tractable ones. Now we'll learn about the central concepts of automata theory. Now we'll see about the central concepts of automata. So first one is alphabet. What is alphabet? An alphabet is a finite, non-empty set of symbols. So the alphabet compulsory, within the set of the alphabet compulsory, even the individual value should be there, because here we have stated it should be the non-empty set of symbols. So conventionally we are going to see the symbol for this alphabet as the summation. So the summation symbol is like this. Okay. So for an alphabet we are going to represent the symbol summation. This one. Example of a alphabet is it can be the set of A and B, 0 or 1, anything. So basically in our subject we are going to have the set of alphabets in the combinations of A, B or C, and the combinations of 0 and 1, etc. Next concept is strings. So what are strings? Strings are nothing but list of symbols from an alphabet. Out of this alphabet only we are going to frame the strings. So here the set of alphabet is with the combinations of A's and B's. Then the strings of this alphabet is going to be like this. Say for example, that can be the combinations of A, B, 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 A. If the alphabet is with the set of zeros and 1 or the combinations of zeros and 1, then the possible string out of this can be 0101, 01 or 0011 like this. So now we'll see about what is empty string. As we have seen just now that for any alphabet we are going to have certain strings, right? Now what is empty string? Empty string is nothing but it is a string with zero occurrences of symbols. So this 0, 0, 1, 1 or A, B, 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 A, these all are the individual symbols. Okay. 1 is a symbol, 0 is a symbol, 1 is a symbol. So these all are the individual symbols within the whole string. Now, what is empty string? Empty string is nothing but it is the empty means which is not having any symbol. It is the zero occurrences of symbol. Okay, and that can be denoted with the epsilon. Our epsilon symbol will come like this. This is the indication of epsilon. Now we'll go to the length of string. It is often useful to classify this string by its length. So that is the number of positions of symbol in the string. Okay. So the notation for the length of string W is like this. We can represent the length of any given string like this. Let us say an example. There is a string W called as AB. Now the length of this W is 4 because how many symbols are there within this string? 1, 2, 3, 4. There are 4 symbols in the given string. So therefore the length of this string is 4. And what about there is a one more string called as V. So the symbols which is there within this string is 0, 1, 0, 0, 1, 1. So what is the length of this string? 1, 2, 3, 4, 5, 6. Hence the length of this string is 6. Next, power of an alphabet. So what is power of an alphabet? If summation is an alphabet, if summation is an alphabet, we can express the set of all string of a certain length from an alphabet by using an exponential notation. So we define this like this, summation raised to k, and symbolically we are going to write this as summation raised to k. So this summation raised to k is the set of string of length k, each of whose symbol is in summation. Example for power of an alphabet. See for example, summation raised to k we have denoted. Now there is a alphabet with the combinations of 0 and 1. Now for this particular combination, the summation raised to 0 will be the epsilon because 0 is nothing but 0 occurrences of symbols. So here epsilon is the empty string which is represented for this summation raised to 0. Now what will be the summation raised to 1? Summation raised to 1 will be the combinations of single digits. So single digits are nothing but only the occurrences of the strings with the combinations of zeros and ones with the length 1. So with the length 1 is 0 and 1. Only these two will come. If the summation raised to 2 is nothing but the strings with the combinations of zeros and ones whose length will be 2. So here 0, 0, 1, 1, 0, 1, 1, 0 will be the set under summation raised to 2. So what will be summation raised to 3 now? So the set of strings whose length is 3 with the combinations of this 0 and 1. So that can be 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1, and so on we can get. But the thing which we are going to concentrate here is whatever the k value we are taking, the length of the string should be that only. It should match with this value. So here it is 2. Our individual strings are of the length 2. So here our individual strings are of length 1. Here it is indicating epsilon. Epsilon is nothing but the empty string. So this empty string is represented with the epsilon. So that epsilon is being taken here. So now we'll see about the next one, that is concatenation of string. Let x and y be strings. Then xy denotes the concatenation of x and y. So in the example, let x be an individual string whose symbols are the combinations of A, B, A. Now, next is Y, one more string whose contents are B, B, A. Now, if we concat this X and Y, then the contents of this A, B, A and B, B, A will be attached. Okay. So here Y is coming after X. Therefore, the content of Y will come after the content of X. So first A, B, A, then B, B, A. So this is the concatenation of string. Next is languages. So what are languages? So these are the set of strings, all of which are chosen from particular alphabet is called a language. So say for example, if summation is an alphabet, then L is the language which is the subset of this summation star, right? So here star indicates inclusion of this epsilon. So L is the language which is the subset of this summation star. So that can be represented like this. Then L is a language over summation. So this means that there are certain conditions and those conditions are called as language. So I have taken one example, that is the language of all strings consisting of n zeros followed by n ones for some n greater than or equal to 0. So here it is clearly mentioned that the alphabet, the set of alphabet is 0, 1 because they said us that it is the combinations of n number of zeros and n number of ones. So because of that our set will become summation 0, 1. Now what is L? So our language is, so they have given some constraint to us, that is consisting of n number of zeros followed by n number of ones. So here after n number of zeros only n number of ones should get repeat. So now the possible sets of combinations of zeros and ones will be like this: 0, 1, 0, 0, 1, 0, 0, 0, 1, 1 or 0, 1, 1, 0, 1, 1, 1, 1 and so on. So in the given example for this particular language, we can observe this that after n number of zeros, there are n number of ones. There are n number of ones. So it is the condition that one number should come after the n number of zeros. So 1 should get after 1 but not before the 0 or in middle of 0. So The possible strings which will not come under this languages are 1 0 will not come, then 0 1 0 will not come, will not be considered, then 0 0 0 1 1 1 0 will not be considered. Why these all are not considered? Because here 1 is coming before the 0. Actually, what is our constraint is n number of zeros followed by n number of ones. So after the 0 only one the number 1 should come. So that is, this is the right possible one and this is the wrong possible for the given language. So therefore the language is this where it belongs to certain conditions on this summation, that is combinations of zeros and ones.